Okay, IPv6 addressing. So in the pre-recording, I actually talked on IPv4, and now we'll be looking at IPv6 addressing. So I'll also do a pre-recording for IPv6 as well to be able to address one or two questions. But before I do that, I'll be running up with the IPv4 pre-recording by tomorrow. So you're going to have another step further on IPv4. But today we'll look at IPv6 addressing proper. And of course, expect to do chapter exam on this. And let's see what you'll be able to come up with. So quickly, let's look at the objective for this particular topic. We'll have to explain the need for IPv6 addressing, explain how IPv6 addresses are represented. We'll compare types of IPv6 network addresses. We'll look at how to configure static global unicast and link local IPv6 network addresses. And then look at how to configure global unicast addresses dynamically. So let's look at this. Before the IPv6 came about, there was real depletion of IPv4. So there was need to come up with an IP scheme that will be able to address the shortfall. And that was how IPv6 emerged. So the need for IPv6 is IPv4 is running out of addresses. IPv6 is the successor of IPv4. IPv6 has a much larger number in terms of space, which is 128-bit address. The development of IPv6 also included fixes for IPv4 limitations and other enhancements. So in other words, IPv6 came to help to take care of the limitations of IPv4. Looking at IPv6, you're talking about 3.4 undercillion. That's quite a huge number. So, I mean, we won't be able to exhaust that number of IP addresses. With an increasing internet population, a limited IPv4 address space, issues with NAT and the IoT, the time has come to begin the transition to IPv6. You can imagine with the emergence of IoT, where everything is beginning to be connected to the internet. So that means without IPv6, it will be difficult for IPv4 to be able to provide that number of IP addresses that could be assigned to much of this equipment that are being connected to the internet. So both IPv4 and IPv6 can coexist in the near future, and the transition will take several years. The IETF has created various protocols and tools to help network administrators. And what they come up with, these migration techniques can be divided into three. So we're looking at the migration from IPv4 to IPv6. And they are of three categories. One, dual stack. In the dual stack category, the devices run both IPv4 and IPv6 simultaneously. So you're going to see topologies that have IPv4 and IPv6. So you're expected to be able to configure that. And tunneling is a method of transporting an IPv6 packet over an IPv4 network. So one of the ways to actually transport IPv6 over an IPv4 network, and then the IPv6 packet is encapsulated inside an IPv4 packet. Then translation. This is in the case where you're using NAT64. Remember, in the case of IPv4, you're talking about NAT itself. So when it's NAT, which is network address translation, is actually for IPv4. But when you hear NAT64, it means that you're looking at IPv version 6. Also note that when we talk about NAT, it's trying to see how you can announce all the private IP addresses on the public domain. So note, tunneling and translation are for transitioning to native IPv6 and should only be used where needed. That's when you use the tunneling approach. So IPv6 address representation. If you look at IPv6, like we said earlier, it's 128-bit length. IPv6 addresses are not case sensitive and can be written in either lowercase or uppercase. So in case you're writing your IPv6, remember you can use it is not case sensitive. And IPv6, a hextent You can see a hextent is what? Is the unofficial term used to refer to a segment of 16 bits or 4 hexadecimal values. So you can see here that in this example given here, 2001 is 4, if you look at it very well, is 4 hexadecimal values. So if you convert 1 to hexadecimal, you know what that gives you. If you convert 0, the same thing. So we're saying put together, it gives you a hextent. And this hextent is actually 16 bits. And then it's being separated by a column. So this is how you write out an IPv6. Okay, so we'll look at the next example. Now, there are rules for managing IPv6. What are the rules? Rule number 1 is omitting the leading zeros. Omitting the leading zeros means that when you have an IPv6, you can actually take off the 0 bits that are in front of any of the values. Is allowed because that's one of the ways to manage IPv6. If you look at the entire length of IPv6, it's quite long, very, very long. So there's a need for you to be able to find a way to manage that. So if in any of the hextents you have, for instance, you have 01AB, we are saying it can also be written as A1AB. If you have 09F0, you can also write it as 9F0. So you can see that the leading zeros have been removed in this case. And in this case, you have 0A00. You can see the zero here has been removed, but then you cannot remove the zeros after any of these numbers. So please note this, that it's only the leading zeros that can be removed. Here you have 00AB. The 2 zeros are removed and left as AB. The system or the network will always know that as long as you're using IPv6, if you write AB, the system as well can actually interpret it as 00AB. So please note that as well. So here you can see what is written here, the normal IPv6, and then removing the leading zeros, you're going to have DB8, 0, column 11, column 0, column 000. You can see that. That's because all the zeros are removed, and then you can leave one of those zeros in the case when all are zeros. But then further steps, you can now see that where you have all 000 like this, you can replace them with a double column. I think that would be rule number 2 here. So rule number 2 is a double column can replace any single contiguous string of 1 or more 16 hexten consisting of all zeros. So in this case, 200DB8, CAFE 101, column 0, column 0, column 0, column 1, could be represented as 2001, column DB8, column CAFE, column 1, double column 1. In this case, because we have replaced all the contiguous string that are having 00 as a hextent to be double column. For your information, you can only create 1 double column. So you're not going to have 2 of double columns. So always note that. And those 0 bits must be contiguous in the sense that they must be next to each other. For instance, you have these, next will be these, and then same. So if you have anyone with, for instance, if you have 000 and you now have maybe 09ABC or something before another 00, you're not going to actually replace with double column. You're going to, the rule says that it's only when it is contiguous that you can actually replace it with double column. So please note that, very important. Any question with that before I go any further? I think it's one sensitive area that everybody needs to note, because when you're configuring this on the network, you also do the same thing. Any question?
Yes. Is that why, where we have this compressed now? We have 2001, DB8, then we have 0. Ordinarily, we could be tempted to represent it with double column.
Exactly.
But we have where we can use double column.
Okay.
In the yes.
Yeah.
You see, you have used 0 now in the beginning. So we cannot have 2 different double columns.
Exactly.
So we either use it in one area.
And the double column must
Is
be
that
one.
why?
Yeah, you
Yeah,
have
it
to use
must be
double
one.
column one. Exactly. That was how it came about to be. So you might be tempted to do another double column here, but you won't need to do that because there's already room for that.
Yeah.
So I think you're in order, or you're not clear?
Yeah. Very clear. That I'm just re-emphasizing so that
Yes.
others can see.
Okay. So what about the rest of us? Are we okay with this before we go any further?
Yes, sir.
Okay, we are all good with this.
Yes,
Yes.
sir.
Okay, thank you very much. So IPv6 address types, let us see the different types. We have IPv6 as, there are three broad categories of IPv6. One is unicast. Unicast is usually identifies an interface on an IPv6 enabled device. Remember unicast, for IPv6, you're looking at it on the interface itself when you are enabling devices. One-to-one is unicast. And then for multicast is used to send a single IPv6 packet to multiple destinations, not far-fetched from what you know with the IPv4. And then any cast, this is any IPv6 unicast address that can be assigned to multiple devices. A packet sent to an any cast address is routed to the nearest device having that address. So that means it can any IPv6 unicast address that can be assigned to multiple devices is referred to as anycast. I'll also try to see if we could get one or two examples to address this. Note, unlike IPv4, IPv6 does not have a broadcast address. I think it's important because when you listen to the last pre-recording, you realize that I mentioned broadcast address. It didn't showed us how you can be able to identify your broadcast address. But in the case of IPv6, IPv6 does not have a broadcast address. Where is this noise coming from? Is the noise coming from somewhere? Okay. So IPv6 prefix length. If you can hear me clearly, can you hear me? You can use it. You can use the hand icon there.
Yes.
Okay, thank you.
We're hearing.
So, okay, so the IPv6 prefix length, the prefix length is represented in a slash notation and is used to indicate the network portion of an IPv6. So if you look at it very well, IPv6 is 128 bits length. So half of it tells you the prefix for your network, and then the remaining 64 bits is for your interface ID. In the case of IPv4, we refer to it as the host and the network. But here in IPv6, it's seen as prefix and interface, but it's quite similar. So it means that for your, you can see example 2000 column DB8 column A and then double column /64. If you have this kind of IPv6 address, it's telling you that fine, you have 200, that means the first four hextens is the prefix, and then the last four hextens is the interface ID, which also can be seen as the host. That is the one you assign to your host devices. Please note that as well. So unlike IPv4 devices that have only a single address, IPv6 addresses typically have two unicast addresses. And what are they? It has what we call the global unicast address and then the link local address. The global unicast address is similar to public IPv4 address. These are global unique internet routable addresses. So you can also look at it side by side with the public IP address. In the pre-recording, I showed us how we can actually identify public IP address. And so it means that IPv6 also have the same, and which you must note. And then for the link local address, it's also seen as like the private for IPv4. So required for every IPv6 enabled devices and used to communicate with other devices on the same local link. And another routable are configured to a single link. So they are more or less private based. But then once you enable them, they pick up that IP address. They usually work with the MAC address of your system. I think that is actually what this link local address, that's the way it actually functions. So we're going to drill more on the global unicast address. So that's why when you see those IP addresses with 2000, they are of the global unicast address. So you can see here IPv6 unicast address being split into global unicast, link local, loopback, unspecified address, unique local, and then embedded IPv4. Now, for the global unicast, we have said is more or less like the public IPv6. The link local actually is like the private of IPv6. The loopback, which is all double column, you can say double column 1/128, is like the loopback you have in IPv4, where you have 127.0.0.1 as loopback IP address, IPv4 address. So in the case of IPv6, it is actually double column 1/128. And then unspecified address is just like when you have unspecified also address for IPv4. For instance, if you enable a DHCP on your intranet network, and for one or two reasons, probably your DHCP is not dishing out IP addresses, you discover that because it's unspecified, your system will naturally pick up an IP address. For IPv4 is 169.0.0.0 stuff. So you can pick up the IP address within that IP network. But for IPv6, we are saying it is actually double column 1/128. Okay. And then for unique local, you can see the unique local FC00 double column /7, and to the range of FDFF double column /7. So telling you that this you can use as unique local, but the unique local, like I mentioned, is actually like a private IPv6 address, but actually gets its IPv6 the complete 68, 8 extent from 48 bit of it is gotten from the MAC address of the computer. And then embedded IPv4, that is when you have IPv4 embedded in IPv6. So we've actually mentioned this already, the range for the unique local addresses. And then let's look at a few examples which will help us to be able to identify this better. So I've actually talked about this for the global routing prefix, and I said that is the one for the internet. And then the subnet ID, it's actually the 4th extent. So if you recall, let me take you back one step further. If you recall, when we gave an example of this nature, this is 1, 2, 3. Let me see. This one shows an IP address, IPv6 address. Okay, look at this one. 200 column ZDB8 column 000 column 1. Now, if you count the hexen, this is 1, 2, 3, 4. Now, this number 4, the 4th hexen here, is actually the subnet for an IPv6. So the next time you write an IPv6, you're not doing any calculation for the subnet. Rather, you just go straight to the 4th hexen. So, like in the case of this one, somebody is 1111. I can come up again and say 1112, 1113. You know, I can just keep adding 1 and then use it as a new subnet for the next network. So please, you need to note that, very important. So, okay, then this is where we are. Subnet ID, I've just mentioned that, is the area between the global routing prefix and the interface ID. So the subnet ID is used by Baze to identify subnet within each site. So that means for every subnet, you just have to use the 4th extent. It's part of the rule for IPv6. So the interface ID, IPv6 interface ID is equivalent to the host portion of an IPv4. So when you hear interface ID, and then you hear host portion, for IPv4. Please, they are the same thing, but just that we need to distinguish one from the other. So for IPv6, you say interface ID. An IPv6 link local enables the device to communicate with other IPv6 enabled devices on the same link and only on that link subnet. So packet within a source or destination link local address cannot be routed. It has to be within the same subnet for it to be able to communicate. So every IPv6 enabled network interface must have an LL, that is the link local address. If an link local address is not configured manually on an interface, the device will automatically create one itself. IPv6 link local address are in the format FE80 /10 of range. That means it's telling you that the first hextent, actually it's in the first hextent, which is 16-bit. So when you're saying /10, /10 is going to be on the first hextent. So you're not going any beyond. And then here you have the global unicast and then the link local address static configuration. So how do you statically configure this network? The command to use here is this. You go to the interface and then you put IPv6 address /64, and then you issue no shutdown, and blah, you go. The double column 1 means the first, there's 1 here means the first usable. You can put 2, you can put 3, and then you configure. And then it will definitely accept it, and then you're good to go. I'll give us a topology at the end of this also to practice, and then get back to me if you have an issue with that. And then if you're going to assign this same static global unicast address to your system, if you check the icon of the network on your laptop, you discover that you can actually assign IPv4 and IPv6. Before now, most of these Windows operating system can only give you provision for IPv4. But now we now have the modern Windows window operating system providing this kind of interface for IPv6. So this is how you write your IPv6. You put the IPv6 address. When you want to assign it to a system, you put a subnet, and then you go ahead to put the default gateway. And then once you OK it, invariably you've assigned it. So the same thing to the simulator, you're also going to assign this as well. So you can see how you do the configuration. Very straightforward. Once you put this IPv6 address, this link local, and then you issue no shutdown. That's in the case of the link local. And then for dynamic addressing, what do you do? In the case of dynamic addressing, let me show us quickly. Dynamic means that when you want to do it automatically, what do you do to configure it automatically? So let's quickly look at the configuration that addresses dynamic processes. So please, I also want to show us this, that the same thing for ipconfig. Once you issue the ipconfig, it displays what you have on your system. So the same command that works for the IPv4 also works for the IPv6. So this is the way I'm trying to look for a configuration that addresses the dynamic for IPv6. So let's see if there is. I think there's none here. Okay, let's go back. I think there's none. I'm going to create one for us. Time. Let's walk through the slide first. So normally for your IPv, for dynamic, dynamic is to configure it such that at least you don't need to do it manually. So how do you do that? In the case of dynamic for IPv6, what happened here is you still work with the link local. The link local will have to be enabled before you apply your global unicast address. And then note this, that once for you to enable enable that interface, what do? You configure the IP address in the router, you configure the IPv6 addressing on the server, and then on the client system, and then you test connectivity. So these are the steps to take. But first, you enable the link local address before assigning the global unicast address. I'm going to get an example to actually differentiate that for us, so that in case you're doing any configuration, you have to know what to do. So once you do that, automatically it will start sending packets from one system to the other. So selected node for IPv6 multicast. Remember we said multicast is when you're sending to a group of systems. So this is a more or less a representative to show that as well for IPv6. So let's now talk about subnet, subnet and IPv6 network. Like I told you, there's no calculation much to do here. The subnet is actually on the 4th extent, which is the 16, where you have after the 48 bits. Remember this 48 bits, that's 16 times 3 gives you 48, which is the global routing prefix. And then the 4th one, which of course is also a 16 bit, is where you have the subnet ID. So you need to actually just have this at the back of your mind, and then you're good to go. So looking at this rundown of networks given to us here, you quite agree with me that these are all IPv6 networks. But then one common factor here that is used to differentiate between one network from the other, you can see that on the 4th extent, here the first one is 000, the second one is 001, 002. So if you design your own topology, you can actually just work with this kind of network. So you don't need to bother yourself trying to create one. There is 20001 column DB8, column ACAD. Please, for your information, this is the global unicast address. So in case you keep seeing these addresses and you keep wondering when will this address change, it wouldn't change because the global unicast address. So you begin to expect some kind of changes from the 4th extent, 5th extent, and above. So for the first 3 extent, it's going to almost be constant for you all through the IPv6 design. So please, I want you to note that and then have it at the back of your mind so that you don't expect to see more changes in that area. But then if you are generating your own subnet, you can actually begin to vary those numbers in the 4th extent. And then once you do that, you're good to go. Now you can see this design. I want everybody to actually create this design on their packet tracer, and then just try to assign these IP addresses on the interfaces on your own, and let's see how you can get that done. Just go to each of these interfaces and assign the IP addresses as it were. So everybody should be able to do this and then send back to me. On the system also, you double click on the system. There's a provision for assigning this IP address. Assign it, and if you have any issue, we'll get to work on it. And then Sir Julius, you need to remind me, in the next class, we'll all look at this together. I'll get to configure it again, so that those of us who have done it were able to see the correction to make. So I just want to see that everybody actually hit the packet tracer and then assign an IPv6 address. Now, if you look at this design, you will agree with me that each of these IPv6 network are not the same. So it means that you have 1, 2, 3, 4, 4, and then you have 5. You have 5 IPv6 network. Can we note that here, please? And the 5 IPv6 network are what you're seeing on the right-hand side here. Is it clear?
Yes.
So can we all agree here that what this design has put into consideration the 5 IPv6 network on the right-hand side?
Yes.
Good. So, and then you've been given the usable IP addresses. So what I just want you to do now is that go into the, do this design in the packet tracer, click on each of these router, And let's all use the 400 series router. So please, you can use the 4231 or lesser, but then make sure you maintain the same 400 series Cisco router. So the 4000 Cisco router. And then for the switches, you can use 5960 Cisco switch. And then you can now drag your system up. So I want everybody to get it done. I hope my assignment is not becoming too much for you.
Which switch did you
No,
say we should
no.
use?
Is that
Which switch did you say we should use?
the 2960 Cisco switch?
Okay.
Okay.
So the example shows that each of the router interfaces on R1 has been configured to be on a different IPv6. That's exactly what we want to confirm. We want to see how we can configure each router with its own IPv6 subnet. So if you're able to do this configuration, you will now be able to see how you can put different subnetting of IPv6 on different topology. I mean, that will really give you a strong guide. And then if you look at this configuration here, they're giving you a guide already. So just the interface and then IPv6 address, you put the global unicast address /64, and then you issue a no shutdown. Once you do that, the interface will come up. So you can actually use this command here as a guide to be able to carry out the practice. And then once you do that, you do the quizzes, and then you write the exam. Any questions so far on this, please? I really want question on this IPv6 please, because people look at it as if it's difficult, but if you ask me, it's one of the simplest because you don't do any manipulation of numbers. Rather, it's just for you to just obey the rules. So it's like here you're obeying rules, but in IPv4 you're actually working it out yourself. So is there any question here?
I think now that means you have two assignments, right? The one in the other video and this particular one we are seeing.
The other video is an assignment on IPv4, but here is an assignment.
Yes. So these are there are two. That means there are two assignments.
Yeah, there's two assignments now. So when you watch the pre-recording, then you do that assignment, and then you watch this one also. When you get to this slide 56, you design this topology on your packet tracer, and then you configure it. And a kind of a guide has been given here for router 1. But I think there's no guide for router 2. So when you finish this router 1, you use the same format to configure router 2, and then the same thing and then you try to see, if I were you, what you do is that you add another extra system to switch 1 so that you can be able to test connectivity between two systems on switch 1. Because as it were, you won't be on PC1 and be able to ping PC4. It's not going to work except you apply some routing protocol. But then there's need for us to test all of that after we have configured it by using the same configuration pattern. So this is how you configure an IPv6 on any given network. But remember, you won't just hit your packet tracer and then start issuing the IP address. You always will start with enable config T before this interface will come up. I hope you know that. So don't just go there and start putting
So can we manually assign IPv6 address?
Yes, we can. That's what we're doing. You're going to do here.
Okay, we'll generate it manually.
Yes, to generate it manually.
Okay.
Yeah.
So you mentioned about the link local address.
Yeah, I see the link local address is actually the private. It's like private Baze IP address. It is not the global unicast address. But in most, or in fact, in virtually all the topologies, the word you configure is actually the global unicast IP address, because the link local is more or less enabled by default on the system.
Okay, we don't need to set it. There's one he said we should set. We should configure in the IPv6. You mentioned something like that.
No, what I'm saying for the link local, I'm saying once you enable the interface, the the private link local is generated. It's generated with the help of the MAC address of the.
Okay.
Yes. It takes some part of the MAC address of the system to form the entire link local address. Yeah.
All right, sir. All right, thank you very much.
You're welcome. So you need to
How
just,
do we
then
how do we avoid the broadcast and multicast IP addresses when it comes to IPv6?
you know,
IPv6.
IPv6 does not have broadcast.
Okay.
Yes, IPv6 does not have broadcast. But in the case of the multicast on IPv6, like what we said is that multicast is when you're saying to a group of selected system. So that is quite different here. And then if you look at it, it all depends on which services or you want to run. Like if you look at IPv4 for the multicast, there are some special services on the network that uses the multicast. So the same like maybe when you're listening to radio on the internet, that's actually multicast channel for the IPv4. So the same thing also applicable for the IPv6. But when it comes to broadcast itself, we don't have any reserved set of IP addresses for the IPv6. So there's no broadcast. And that one of the, that's like somebody asking you to differentiate between IPv4 and IPv6. I think it's one of the clear factor there that you can say this has a broadcast and this does not have a broadcast.
Okay, sir. In previous lectures, we also discussed the fact that with IP4, we have the broadcast, multicast, and we said that what differentiates it from IPv6 is the anycast. Remember? Anycast.
Yes, we say anycast, yeah.
So where does anycast come to play in this?
Okay, you mean in terms of the in what regard now? You mean in the IP address itself?
Yeah, in the IP addressing system, and how do we identify it or know how to stay away from it or use it when the need arises?
There's a statement we made here, if you recall. I'm trying to take us back so that it will help us. We said we said IPv6 unicast address that can be assigned to multiple devices. A packet sent to any cast address is routed to the nearest device having that address. So if you look at what any cast is here, any cast, listen here, this is any IPv6 unicast. So what we've been talking about is on unicast. Unicast is where you have your global unicast, you have your link local, you have your unspecified address, you have your loopback address. But here is saying that once you have a unicast address that can be assigned to multiple devices, a packet sent to any anycast address is routed to the nearest device having that address. So automatically, you're not doing anything, but it will on its own. So all we're saying is a kind of a dynamic setup that as soon as you have any unicast IPv6 unicast address that is assigned to multiple devices, the packet itself will send any anycast address to the nearest device having that particular address. So it's more or less it's like a decision, what do we call it, a protocol that's already incorporated into the design. That on its own, it just identify the nearest device and then send the packet. I don't know if you get what I'm saying. So you will not actually say this specified or group of IPv6 address is for anycast. No, rather you just look at it from the angle of a protocol already incorporated into the design of IPv6 that once you have the unicast address that is assigned to multiple devices and then sent to any anycast address, it's routed to the nearest device having that particular address. And what is anycast? If you look at I don't know if we got that definition here. I don't know if it's this. I don't know if we mentioned it here. So you don't have any particular group of address under IPv6 that you refer to as anycast. I don't know if that addresses your question. Hello, Umaru. Is it Umaru or?
I can hear you, sir. I'm here with you.
Okay.
I think if I understand, in IPv6, it is possible for two devices to have the same address.
Yeah, very possible.
So if you send the anycast, it will send to the nearest one to it.
It is sent to the nearest one.
To the nearest one with that address.
With that same address.
Okay. All right. Thank you very much. Okay.
Remember, all these are just more or less. It's like a program. You're right, but it's already incorporated in the design itself. But we need to just read through the curriculum and then attempt those quizzes to help us a lot. But does it answer your question, please?
It does. It does, sir.
Okay. So that is for. But I can still see it's like we're too busy. Well, some of us are still not writing the module. Is Julius there?
Yes, I'm there. I'm looking at this assignment.
Okay, the assignment. It's like you're really bothered with the assignment.
So.
No, the assignment is for actually practice.
Hands-on is better. Yes.
The assignment is for practice.
Yes.
The assignment is for practice because, like I said,
yes.
at the end of the day, you need to do more practical so that the student can actually follow whatever we're doing. So our advice that we try to do as many practical as possible. It's very important. And the more you practice this configuration, the better. If you practice often, you find it very easy. If you don't practice it, then that is where you have a lot of issues. Some of these things that you just look at on the screen and say, no, this is simple. If you don't practice it, by the time you want to do it on your own, you still find it difficult to do. But once you practice it, it will stick. That's the secret. So we'll just look at the next, because once we finish this, I'll now put the rest of the time into practicals, and then I'm sure so that at least one we can hand off this program on time, and then most of you can go back to the normal activities. I know it has really been a big sacrifice on your own part as well. But then once you finish it and you incorporate it into your curriculum, and then start teaching the student, in the next 3-4 months, most of you become highly professional in this area. Can we see this slide, please?
Yes.
Okay. This slide, this particular slide is not much. It has to do with the ICMP. An ICMP is Internet Control Message Protocol. In summary, what your ICMP, let's see what we have on the learning objective so that it will help us. Let me see if I have something here. Okay, we'll explain how the ICMP is used to test network connectivity, and then use ping and test route utilities to test network connectivity. So if you look at it even from the objective, it just gives you some kind of clear, gives a clear cut that ICMP is specifically for testing connectivity. So it's like sending an echo. So each time you ping and then you get a feedback, the feedback will either be not reachable or timeout or to reply normal. So we are saying that protocol, that services that is used to carry out that testing is through the help of the ICMP, which is the Internet Control Message Protocol. So you need to know that. So for ICMP version 4 and ICMP version 6. So remember, since you have IP address version 4, so you expect to have its own protocol for testing connectivity, same thing for IPv6. So IPv4 is the message protocol for IPv4, while ICMPv6 is the messaging protocol for IPv6, as the case may be. And what happened here, it includes host reachability, destination or service unreachable, and then time exceeded. So let's see if we have, so destination or service unreachable. An ICMP destination unreachable message can be used to notify the source that the destination or service is what? Unreachable. So if you ping, for instance, you ping an IP address that is not enabled, or probably is not within the loop of your IP, if you ping it, it will show you unreachable. In some cases, it will tell you timeout, you know. So what we're saying here is that these are the different ways in which the ICMP operates. So for IPv4, net unreachable, host unreachable, protocol unreachable, port unreachable. A few destination unreachable codes for IPv6 are as follows: no route to destination. Communication with the destination is administratively prohibited, e.g. when there's a firewall, beyond scope of the source address. So you might have different kind of feedback, you know, and this feedback are now put in these orders. So we're just saying that this is still part of testing connectivity. So here, when the time to leave, which is a TTL, in a packet is decremented to 0, then ICMPv4 time exceeded message will be sent to the source host. Remember when you ping and you see something like this, you see TTL means time to leave. I would say it's decremental by 1. So definitely once it gets to 0, it shows that it has exceeded its time, lifetime, and then that packet will automatically be discarded or it has reached its limit. So an IPv6 also sends a time exceeded message instead instead of the IPv4 TTL field. ICMPv6 uses the IPv6 hop limit field to determine if the packet has expired. So these are the ways that you can distinguish between the two of them. Okay, so I think this particular curriculum won't really give us much of an issue, because all you're just doing is doing testing for connectivity from one point, from a host to destination. So here also you have it as ping and trace route test. Remember what the ping is. Ping is also test for connectivity. Okay, so the ping command is an IPv4, and IPv6 testing utility that uses ICMP echo request and echo reply message to test connectivity between hosts and provide a summary that include the success rate and average round trip to the destination. So you always see that. And then another thing also you observe from this is that when you ping, it tells you the average time. Sometimes if you ping on the wireless, you see maybe like 1,200 and something milliseconds and then time to leave. So that round trip time average tells you whether you're on a slow network, whether you're a fast network, and all of that. If you're seeing 1 millisecond, then that's fast enough. So you can actually use this to tell the speed of the network once you ping as well. So you can ping the loop back address to text for connectivity on your system, and then see how that works. You ping the default gateway. So this pinging thing is one thing you cannot take out from any network engineer. You must always ping to test connectivity, to test default gateway, to test if the host is still available. And in the case of trace route, for trace route, this is a command. You say trace route, you put the IP address you want to trace, and it gives you all the IP addresses in that particular lineup or topology, or the different hops that it has to go through before getting to the destination device. So trace route provides round trip time for each hop along the path and indicates if a hop fails to respond. So an asterisk is used to indicate a lost or unreplied packet. This result is quite important. Oftentimes, even some of these hackers, when they use falsified gateway or whatever, once you use a trace route on the network, you can be able to tell the number of hops along in that connection and can trace exactly where the person is. So there's not like falsifying any gateway. Rather, it will just show you those IP networks or IP addresses along that connection. So traceroute is a very strong tool in testing for connectivity along the entire part of the network. So I would love us to do those practice on our own, and then if you have issues with that, do let me know. But it's actually obviously used for testing for connectivity. Okay. So if you look at what we have in module 14, module 14 has to do with the transport layer. I've sent all these slides to us. Sir Julius, I don't know if you have gotten it.
Yes, everybody has. Everybody
no.
has that.
I have up to 13. I don't have up to 14.
No,
Oh, really?
check our combined email. Let him check our combined email.
Yeah, is that Sam? Who said it does not have all?
It's Sam. I have up to 13.
We didn't check. Check your email.
Okay, sir. I will check.
Sam, check. I have sent all the slides. Because this is the same slide you're going to use as instructors. And at the end of this training, I will enable all your account as instructors. So next time you'll be logging in, you also have the ability to download this same material yourself. And you can also download the lab manual for the instructor yourself. Once you download the lab manual, the solution to the lab activity is in the lab manual. So in case you give it to your student, while your students are doing it, you have the instructor manual and be checking to see if probably doing the right thing or not. So I advise that we look forward to all the resources that you can access as an instructor. But of course, like I told us at the beginning part of the course, that I'm going to have an orientation class for us on how to navigate around the platform so that you now know what and what you should be able to do as an instructor. So module 14 is the transport layer. And the transport layer, who can tell me what layer, at what layer constitute the transport layer? Which of the layer?
It's layer 4.
Layer 4, thank you very much. So it's in layer 4, we have the transport layer. So here we're going to explain the core transport layer in managing transportation of data in end-to-end communication. Explain characteristics of the TCP. We'll look at characteristics of the UDP, explain how TCP and UDP uses port numbers, how TCP section establishment and termination processes facilitate reliable communication, and how TCP protocol data units are transmitted and acknowledged to guarantee delivery. Compare the operations of transport layer protocols in supporting end-to-end communication. Invariably, when you talk about a transport layer, two things comes to mind. The transport layer has two sides, either the TCP or the UDP. Your TCP is the transmission control protocol, and then your UDP is the user datagram protocol. So we have agreed that the transport layer is on layer 4. So from here you can see from the TCP IP is actually you can see here after the application layer you have a transport layer. But looking at it from the OSI model, it's actually on layer 4. So the transport layer has the following responsibilities. So in case you want to see what are the responsibilities of the transport layer, tracking individual conversation, segmenting data and reassembling segments. So it is segmentation actually takes place at the transport layer. Add header information. So there's a header information that is added, which actually form the segment. Identify, separate, and manage multiple conversations. So you can identify and separate. Why will you do that? It will be able to identify voice, video, and data, because that is where the main transportation takes place. So that means it's that layer that can help tell that this is a voice, this is a video, and this is video packet and all of that. So it uses segmentation and multiplexing to enable different communication conversation to be interleaved on the same network, more or less to make it like a unified network. So if you have it broken down into those different category of data types, we are saying that it's doing this with the help of interleaving those packets. So the transport layer protocols, what does it do? IP does not specify how the delivery or transportation of the packet takes place. So if you look at it here, the TCP and the UDP, we're telling you that the example of the TCP is the FTP, your HTTP, SMTP. An example of the UDP here is DNS and TFTP. It tells you that you have DNS for TCP, you also have DNS for UDP. Remember, the DNS here is a domain name service. So notice here that your transport layer is broken down into two. So at the internet layer, internet itself, which is the IP, there's a connection to the TCP and the UDP. So this is more or less a connection showing you that the transport layer plays a vital role in the entire communication flow. And obviously, when you study the OSI model again and over again, you see that one of the layers that actually has its link to all the other layers is the transport layer. So it sits at the middle and have that connectivity because it plays a very vital role. So it actually does what we call end-to-end data integrity. So it's meant to actually handle transmission of data from the source to its destination. So the transport layer includes the TCP and the UDP protocol. So you must note that. And then the TCP provides reliability and flow control. TCP basic operations include number and track data segment, acknowledgement, retransmit any unacknowledged data after a certain amount of time. So it does retransmission if there's a failure, and then the sequence data might arrive in wrong order, send data at any efficient rate that is acceptable. So you have all these as attributes of the TCP. So the TCP will actually do acknowledgement and try to send when there's a failure. But in the case of the UDP, is the reverse. It does not function in this way. So UDP provides the basic function. And here you can see the UDP is a connectionless protocol. UDP is known as the best effort delivery protocol because there is no acknowledgement. So please note this, there's no acknowledgement in UDP. And that's the reason why you can watch a live football on the internet. Even when there are issues, it does not retransmit. Even when there are anything, it doesn't. So that live football you watch on the internet is actually through the UDP connection on the transport layer. So the right transport layer protocol for the right application. So like we said, there are different applications or services that run through the transport layer, and they all have to go through the different means here. So here you can see your voice as VoIP is on the UDP. And then you also see here that your resolution DNS is on the UDP. And then when it comes to TCP, your SMTP, which is your simple mail transfer protocol, which uses port 25, actually is on TCP, and then your HTTP, World Wide Web, where you type on the URL or whatever to send one or two, is on the TCP. So here it is reliable, acknowledges data, retransmit or resend lost data, and delivery data in sequence order. But here is actually fast, low overhead, does not require acknowledgement, does not resend lost data. Once it is lost, it is lost. Delivers data as it arrives immediately. So TCP view. So TCP features establish a section and then ensures reliable delivery and provide same order delivery, support flow control. When we talk about establish a section, of course, when a section is established, it's when you have between your source and device, for instance, when you have the source and device synchronizes, and then can now be able to send information. We said that's one of the features of the TCP. And then it's actually a reliable delivery in the sense that it must maintain that data integrity. Be sure that the data that is sent from the source gets to the destination. And if for any reason there's an issue, it will transmit that. And then provide same order delivery, because networks may provide multiple routes that can have different transmission rates. Data can arrive in the wrong order. So it provides same order delivery. And then support flow control. Network hosts have limited resources in terms of memory and processing power. So when TCP is aware that the resources are overtaxed, it can request that the sending application reduce the rate of data flow. And that's why sometimes when you're sending something across the network, you realize that at one point it tells you if you're sending, if this thing you're trying to send, or if you're sending it at, let's say at one point it tell you maybe 3 kbps, if you send at 3 kbps per second, it will take 2 hours. Before you know, again, to tell you to take, if you send at maybe, it will reduce the size, increase the size. So you see that this time variation. Even you yourself, you can, it's just somebody, oh, this is the rate at which you're sending. It's going to take the next 3 hours, so let's go and rest and come back. But after a while, again, it will increase the data transmission to maybe 1.8. And then the time is going to take to actually send all those information might drop again. So you have this irregular timing. So TCP support that kind of process, which is tagged as flow control. And then the TCP header. The TCP header is a stateful protocol, which means it keeps track of the state of the communication section. And it keeps that because it has its connection across the entire layer. TCP records which information it has sent and which information has been what? Acknowledged. So you can see the architecture of a typical TCP header here, where you have the source port and the destination port. And the sequence number, which is 32, and then the acknowledgement number. So you have the header, you have the control bit, and then the window. And all this actually comes from the characteristics of the TCP itself. So, but then one thing that you also need to note here is that it works with port numbers. And that's why you always see that the different services that runs on your network or runs when if you block a particular port, that service won't work on your network. So that's why if you look at most of the common known port numbers, they are there for you to identify them so that you can choose to block them or not. But then they operate, that the TCP works with port numbers. So the TCP header field, so you can see here the different header field of the TCP as shown here, and then giving a description of how many bits they are and all of that. So we're going to advise you walk through that. Applications that uses TCP. TCP handles all tasks associated with dividing the data stream into segments. We've said that before, providing reliability and controlling data flow and reordering segments. So you look at the TCP here, you see here handling your HTTP, your FTP. Your FTP is a file transfer protocol. And who can tell me what is a port number for FTP? All these services you're seeing here, they have their port number. What's the port number for FTP? Have we heard of FTP before? Nobody?
43?
No.
No. I think 21.
FTP is file when you're transferring file across the network. You transfer, either you are sending or you're receiving. I hope you know that.
Yes.
Are we together, please?
Yes.
Yes, we are.
Okay, fine. So we're looking at the application that uses the TCP, and here it is already stated that you have example of some of them, is HTTP, FTP, SMTP, and SSH. So I'm only asking us that This one's mentioned here, if you've come across them. If you haven't, the HTTP is the Hypertext Transfer Protocol, which is port 80. And if it's HTTPS, it's port 443. And then if it's FTP, I just asked down. If it's FTP,
that's 21.
Yeah, 21, thank you. But when it's receiving, when it's receiving is what? You know, when it's sending and receiving, we have different port numbers for them.
20.
Thank you very much. Okay.
20
So
and 21.
20 and 21, thank you. So the SMTP is what?
25.
25, thank you. And then SSH is what? Nobody?
Sorry, SS what?
SSH, the secure shell protocol.
Okay, SSH is 22.
Thank you very
I
much.
think.
Is that Amina?
No, it's
No,
Lukaya.
that's
Huh?
It's Lukaya.
Lukaya.
Okay, thank you very much for that. So, and that's a secure, you know, if you're using Telnet, Telnet is not as secure as SSH. Maybe if you want to connect to your router remotely or whatever. So, what is the port number for Telnet, for instance? We don't know the port number for Telnet.
I think it should be 23.
23. Okay, very good. So you need to know these services or applications and also know their port numbers. Quite important. And the student also needs to know this. So the UDP overview. UDP features include the following: data is reconstructed in the order that is received. Any segment that are lost is completely not resent. That's why when you watch any live movies or somebody calls you on the phone, maybe on WhatsApp or through any of the internet services, once you miss any information, you have missed it. It won't be resent. The sending is not informed. Is not informed about resource availability. So, and that actually makes the architecture quite smaller compared to your TCP. So here you can see it has source, a destination, and then application data. So that means you don't have anything like acknowledgement, you don't have anything like windowing, you don't have flow control and all of that. So here the table identifies and describes the 4 field of the UDP. So we look at this is the application of the UDP. Now here we have a DHCP, we have a DNS, we have a simple network. That's SNMP. SNMP is the simple network. What's the M? Management protocol. And then the TFTP, which is the Trial File Transfer Protocol. And then your VoIP, you know it, which is Voice over Internet Protocol. And then your video conferencing. So I think we're used to DHCP, we know DNS, we know SNMP, Simple Network Management Protocol, and then the TFTP. Now, do we know what TFTP is used for? Have any of us heard of TFTP before?
Trivia.
Sir Julius, you're passing to somebody. Is it?
I said Trivia File Transfer Protocol.
Oh, beautiful. And what is it used for?
I think that's what it is.
What is it used for?
It's for, I think it's more for more security, Abi.
Yeah, the
Trivia
TFTP.
there, the trivia.
The TFTP is the Trial File Transfer Protocol. It's actually used for we use it more often for maybe when you want to update the iOS of the router, you use that Trial File Transfer Protocol. It's actually,
but it doesn't provide more security.
And it doesn't provide more security. That's correct.
No, it doesn't provide, but it's, I think for it to just be, should it be more stable, or the word T there, the T there.
The
Need for
the
for
tribe
it to be more reliable.
more reliable, exactly. So we need to be able to do
Okay,
the
that's
public.
yeah,
So
not
you
more reliable.
it
There's
was
there's a limitation on the packet size and the load of the message that you can send on TFTP.
on TF
Unlike, yeah,
on
the size of
unlike FTP.
unlike FTP, the message, the size of the message you send on FTP is way more than what you can send on TFTP. That's why you can use it for reconfiguration purposes. But if you are saying you want to transfer a message or a file, or I think the load capacity of FTP is bigger than TFTP. That's what I'm trying to say.
And apart from that, when you're doing FTP, for instance, if you look at the iOS of a typical Cisco router, for instance, it contains a lot of very sensitive information, which more or less you can't transfer such in FTP because your FTP is addressing things that has to do with TCP. Remember, when you're looking at this UDP, you're looking at something that you want to transfer once and for all, as quick as fast as possible. You don't want something that will require any form of retransmission or acknowledgement, because if that happens in the case of, which of course happens on FTP, if there's a failure, you try to retransmit, that means that update you're doing on your Cisco router will have some issues, in the sense that if the code is supposed to be maybe 9 bits, for instance, you're going to be having like 10, because maybe one was about to send and did not send properly. It will resend that one again. So what happened is that the TFTP itself is, like you said, it's actually a very short way of sending information across, but then you send it timely and then does not give you the room for any retransmission. But it still operates under the same FTP, more or less file transfer protocol behavior. But then this is quite on a very short and precise mode of sending, which does not require retransmission. So that's why it's called tribal file transfer protocol. So for the DHCP, of course, we know the full meaning of DHCP, right? I don't think we have issue with that.
Dynamic host
Yeah, dynamic host.
transfer protocol.
Okay, so we've talked about these port numbers, and I think you need to let your student know the well-known port numbers. You need to know the well-known port numbers. And then another thing also we need to know is that we have dynamic port numbers. Dynamic port numbers. Your system can dynamically pick port numbers, which is quite different from your well-known port numbers that are assigned to certain applications. So in the case of a server and a client system trying to send information, you see what we have on the right-hand side. You could see, for instance, you have a source port number, which is maybe 1305, and a destination port number, which is 21. Here you can say, okay, you're trying to send because you're looking at port 21. But let me just read out what we have on the socket pair. The source and the destination port are placed within the segment. The segment are then encapsulated within an IP packet. This is more or less a way of trying to differentiate between you having your, please listen here, from if you look at what we have here: destination MAC address, source MAC address, source IP address, destination MAC address. It's just telling you that, of course, if you want to send packets from point A to B, of course, the destination and source MAC address must be known, and then the source IP address and destination IP address also must be known. But then if you look at it critically, you discover that in the bit of trying to send, here is saying that the source port number or the destination IP address and destination port number is known as a socket. So we need to differentiate between what a socket is and a port. The student has once asked before, what's the difference between a socket and a port? So when you have the combination of your source IP address and I think number 3 I actually answered that question. when you have the combination of the source IP address and the source port number, or the destination of the IP address and the destination port number, it is known as a socket. So that means the destination IP address and destination port number, of course, will work hand in hand. And that actually is what is referred to as what? As a socket. So once you have these two known, for either the source or for the destination, is actually what we refer to as a socket. So socket enable multiple processes run on the client to distinguish themselves from each other, and multiple connections to the server processes to be distinguished from each other. So it means that I will have a port number, and then I will have an IP address. So if a port number is 21, for instance, and I now know what the IP address is. Let's say I have an IP address that, sorry, a port number that is 53, and then an IP address which is maybe 8.8.8.8. Now, if I tell you the port address is 53, of course I know what you all know what port 53 is, right? I will come across port 53.
63.
DNS, I think.
Thank you very much. That's DNS. That's a DNS address. So once the port number is known, and then the IP address, for instance, is 8.8.8, we're saying that entire, and actually is the destination device, maybe a server or something, then that particular unit is now known as a socket. Please, you need to note this very well, because you need to actually help this to explain this to your students so they can be able to distinguish between a socket and a port number. I hope this explanation is clear, except if you have any question to ask. Do you have any question here before I go any further?
No.
Okay, thank you. So these are port numbers. So you need to know the well-known port numbers, and then the other set of port numbers. So well-known port numbers are actually from 0 to 1023, which is quite much. And then registered port numbers actually 1024 to 49151, which is quite much as well. But these are registered port numbers. So for example, Cisco has a registered port number of 1812 for its radio server authentication processes. So if it is registered, that means actually the body INA actually also handles that. Remember, we say INA handles IP addresses. So they are also responsible for port numbers as well. So you need to add that. And then the private or dynamic port numbers are from 49152 to 65535. And then these dynamic port numbers are the ones that the system pick dynamically on its own. So these are these are also known as ephemeral port. And then the client OS usually assign port numbers dynamically. So please, I want you to note this. Maybe for instance, you are on HTTP, and then a system A is on maybe on Facebook.com. The system will, of course, you agree with me, on port 80, but it now have something like a kind of a column, maybe 3, 4, 5, 8. Remember here we say 49,152. So I could just pick up a number and say, okay, maybe 50152. So the 50152 will be dynamically picked by the operating system, and we'll put it side by side with that port 80. So it means that you're actually on HTTP, but the system itself has generated its own dynamic port number for ease of identification. Because if two systems are on HTTP, for instance, there's a need for us to further distinguish between the two systems. And that is where dynamic port numbers come into play. So systems can arbitrarily, the OS itself usually assign port number dynamically when a connection to a service is initiated. So once there's that server client service is running, and irrespective of any application that is running, the system on its own dynamically pick an IP addresses from the OS of that system. So I think most of the ones we have mentioned actually are repeated here. You can see 2021 for FTP, you can see 22 for your secure shell, 23 for telnet. You can see your 53 for your DNS. You can see your 80 and all of that, 443 for your hypertext transfer. So students should be able to memorize this set of IP addresses, because when you be, I think in CCNA2 or so 3, when you'll be doing access list control, and there's need for you to disallow any of these services, you should be able to remember the port number. So please, you let them take their time to go through it and be able to memorize them. So for the port numbers, the net start command, which is unexplained TCP connections, can pose a major security threat. So net start is an important tool to verify connections. So here, once you issue this on your system, it gives you the local address, the foreign address, and the state to tell you if connection has been established or not. You can actually even test it out on your own and see that's between the local address and the destination address, and then tells you if it's actually established or not established. So TCP communication, and another TCP server processes. Each application processes run on the server is configured to use a port number. So that we have looked at also. So you can see, for instance, here you're saying 49152. So you agree with me that that 49152 is actually in the category of dynamic port numbers. So you can see how the system on its own will have to pick that. So an individual server cannot have two services assigned to the same port number within the same transport layer service. An active server application assigned to a specific port number is considered open, which means that the transport layer accepts and processes segment addresses to that port. So any incoming client request address to the correct socket is accepted, and the data is what? Passed to the server application. So you can see a typical narrative here at the right-hand side. You guys will agree with me here. For instance, you're using the SMTP, which is the Simple Mail Transfer Protocol, port 25. You can see the destination port number to be 5152. So 5152, which category of port number can we say this is? Is it private? Is it registered? Is it well-known? Or is it dynamic?
Dynamic.
Dynamic.
Okay, dynamic, thank you. So, and then this is the TCP connection established. This is where we also talk about the three-way handshake. So it's send, receive, acknowledge, and then establish. So this is the way the three-way handshake actually works. So for step one, it initiates client request as a client to server communication section. And then two, the server acknowledges, as you can see on the right-hand side. And then the client to server communication section, and then request a server to client communication section. And then three, the initiating client acknowledges the server to client communication, and then on and on you go. So you can see here the sequence. The sequence here is like 100 CTL synchronization, and then it moves. So if you recall when we're talking about the flow control, it has the ability to check to see what the guy can receive. It can acknowledge, maybe increase the number by 1, and vice versa it goes. And then that also now determines how long it will take for this information to be sent completely. So this is for TCP connection. And then for section termination. So when the client has no more data to send in the stream, it sends a segment with the fin flag set, and the server sends an acknowledgement to acknowledge the receipt of the fin to terminate the section to the server. So in the same manner, when there's nothing to send as well, how it ends the process. But remember, for TCP, there's always a feedback to be able to tell at whether it's receiving and it's sending back and all that. So the three-way handshake will explain that also in the process by first of all synchronizing acknowledge, and then information is sent. So here, the 6 control bit flag are as follows. You have the urgent pointer fields are significant. So this is more or less like the architecture of the TCP communication process. For the acknowledgement flag is used to connect connection establishment and section termination, and then the push function, rest, and all of that. So this is just to give you a guide on the entire connection process of the TCP IP. And so there's a video. I think this video also will help when you watch this video for the 3-way handshake and then play that. But I need to ask this question. How many of us actually read through this curriculum page by page? And then secondly, do you play this video when you read them? How many of us have done that? How many of us have actually, I need to say this for the, I need to say this for the record.
Yes.
If you really
I
want
played
to,
I played the video. Okay.
please, you need to do all this. The thing here is that as an instructor, I would advise that after this training, you just take this PowerPoint and dive into the class to start teaching. It would be nice that you also read through the curriculum that the students are going to read. Take your time, at least your spare time, even if it's 30 minutes every day or 1 hour. As you go through the curriculum, I mean, it gives you a broader understanding of the entire topic itself. And then, so that when the students are reading, you know what they are reading. When they ask you questions, you know the kind of questions they ask you, because the curriculum itself gives further explanation. The PowerPoint is just to summarize most of these things. So I advise that you play this video, listen to it, and then take your time to understand everything before you move on. So reliability and flow control. If you look at here, we've actually says that the TCP guaranteed what delivery, that's end-to-end data integrity. So the TCP can also help maintain the flow of packets so that the device will not become overloaded. There may be times when TCP segments do not arrive at the destination or arrive out of order. All data must be received, and the data in this segment must be reassembled into original order. So remember, the TCP, the transport layer will break it down or interleave it into segments. And at the point of reaching the destination, it has to reassemble. So it's possible there can be some form of disorderliness in the process. But we're saying that it also has the ability to resend. So sequence numbers are assigned in the header of each packet to achieve that goal. So you also try and watch the video. And then this is TCP reliability, data loss, and retransmission. So it can retransmit the same data that is lost. So here on this side is showing you at what point it's lost, and then to the right is showing you when it is retransmitted. And of course, when it's retransmitted, then there should be some form of duplicate, because first of all, it is sent, but then it was not received, and then has to resend. So no matter how well designed a network is, data loss occasionally occurs. So TCP provides a method of managing these segment losses. Among these is a mechanism to retransmit segments for unacknowledged data. And that's one of the things that made some of the services or applications are not running on this particular part of the transport layer, because of when it is being retransmitted, you agree with me that it's not going to actually serve that purpose. But it is important here, for instance, when you send a message, the message is not fully received, and then after a while, the person now receives the full message. It's because the transport layer wants to actually resend that to be able to enable the destination or the recipient gets the full information. But that's not the case when you are talking to an individual using maybe voice over IP. It's expected that once you don't hear, you're not hearing that. Because if you must hear me twice or thrice when I'm talking, I don't think you enjoy that kind of conversation. Just like we're having this online virtual class. when I'm talking, at least you're hearing me once and for all. So you're not hearing me, and then probably the part you didn't hear again, we have to retransmit it. It is not necessary and it's not needed because it's actually going to worsen the entire process. So, but then that is why, but then you discover that when the message is sent and it's not fully sent, if it's resent and the recipient receives the full message, that's good. That's why it has to happen on the TCP. So the TCP is actually very reliable in the area of retransmitting any lost data. So we need to watch the video and see how the processes work as well. And then for the flow control, we've also said it here. It provides mechanism for code control. And what does flow control do? Is the amount of data that destination can receive and process reliably. So if the destination can receive more than at a particular point based on what is being sent. So if you're sending, for instance, 10,000, and of course, if you pick a sequence number, we're saying that, and then you have 1,460 bytes being received. It's saying here that, oh, fine, what this guy can be able to receive at this point is 146. And if it's 146, it's going to add 1 to it and say, okay, let's add 1 and see, even though he's going to take this. The guy takes that, then it looks at it again and then add. All is just to check to see what he can be able to take. So we're saying that the TCP flow control is for window size and then for acknowledgement. It helps to be able to tell what the source should send and what the destination can be able to pick at every point in time. Okay. So TCP flow control congestion avoidance. When congestion occurs on the network, it results in packet being discarded by the overloaded router. So to avoid control congestion, TCP employs several congestion handling mechanisms, timers, and algorithms. These are ways to actually help to control congestion and avoidance. Of course, this rarely happens, but once it happens, we're saying that the timer and the algorithm, the timer means that it will wait for a while and then the whole process will start all over again. So for the UDP, UDP, like we said, is user datagram protocol, low overhead versus reliability. So UDP does not establish a connection. UDP provides low overhead data transport because it has a small datagram header and no network management and traffic. So, so UDP does not establish the connection before sending. Because of what? So why is that? Let me ask this question. Why is that UDP does not establish a connection before sending? Can anybody answer this? We know what UDP is. We said it's connection.
Reliable.
The answer is here. The answer is here, but I just want to hear you say.
It breaks the communication into small datagrams that can follow different paths.
Okay.
And can be reassembled when it gets there in the proper order.
Okay.
Primarily, it is connectionless.
Yeah. Okay. And then actually, what was the reason here is that it has a small datagram header and no network management traffic. And that's why it does not really have the ability to establish any connection before.
Is it also safe to say that the datagram header occupies lesser space than the TCP header that will actually include the sequencing?
No, I didn't get what you're saying. The sequencing happens in the TCP.
Yeah.
Mm-hmm.
And I want to assume that it doesn't happen in the datagram.
No, it doesn't. But here, what we're saying that it has a small datagram header and no network management. And this small datagram header that it has actually does not help it to be put, and there's no network management traffic. This small datagram header that it has does not help it to establish any connection before sending. Because actually, in the case of TCP, you know, it has to establish connection. You know, connection must be established in TCP. Are we together, Tom?
Yeah.
UDP does not establish a connection before sending data. But in the case of TCP, it first of all must establish connection because the datagram header actually is robust enough to be able to detect where the destination is, and then before it's sent. But in the case of UDP, it does not. And that's the reason why you start connection. So this small datagram header here is one of the reasons why it does not have the ability to be able to detect the destination point where it is heading to. And once it doesn't know what it just does is that it just sent. He's sending, definitely he knows that the recipient will definitely receive, because of course other protocols on the network are already in place to make sure whatever is sent from the source gets to the destination. But what we're saying is that for the case of the UDP itself, the low header itself does not make it have the ability to be able to establish any connection before sending. And of course, you wouldn't say it has that strong reliability. UDP datagram reassembling, like you said, UDP does not track sequence numbers the way TCP does. UDP has no way to reorder datagram in their transmission order. UDP simply reassembled the data in the order that it was received and forwarded to the application directly. So it has no way to reorder the datagram in their transmission order. And then it just actually reassembled the data in the order that it was received and then forwarded to the application itself directly. So UDP-based server application processing and request. So here you have the server, you have your two clients, the DNS request, and then the radius request on client 2. So here we're trying to look at now UDP based server application are assigned well-known or registered port number. And then 2, UDP receive datagram destined for one of these ports. It forward the application data to the appropriate application based on the port number. So that means it also uses the port identification to be able to send the datagram. What is datagram? So what do we tag as datagram?
That's the packet.
The packet, thank you very much.
UDP packet.
Yeah, the UDP packet. So the datagram at that UDP is known as what?
That's the datagram is a packet, I think.
Right, it's a packet that is in segment. You know, remember at that
segment in transport layer.
See the transport layer. That's it. So the UDP client process. UDP client processes dynamically select a port number from the range of port numbers and uses this as a source port for the conversation. So the senior port number is usually the well-known or registered port number assigned to the server processes. And then after a client has selected the source and destination port, the same pair of ports are used in the header of all datagram in the course of the transaction or sending of information from one point to the other. So once you go through this, you take your quizzes and then see if you have any issues. And the good thing, like I said, is that even when you take the end of module assessment, if you have any, if your grade is not fine by you, you can still take them until you get it right. Because it is a skill-based stuff, so you're meant to read, do the assessment, go back again, on and on until you get it right. So on this note, I think we've actually spent a lot of time here. We'll come to the end, except there are any questions to ask. But then at this junction also, finally, before we leave, I need to ask us, when do we wish to write the final exam? Sir Julius, are you also there? He's not there. Hello?
I'm here.
Okay.
I'm here.
Okay.
I'm with you.
Okay. So when do we wish to write the final exam? We're
Finish
quite.
this lecture today is Thursday. We should finish it this week.
Yes,
Abi?
we'll finish this week. We have 3 slides left. So we'll finish it hopefully tomorrow. What we have left is not it's something that most of you can, I mean, what we have is the application layer, and then we have application layer, which is about what something slides, and then we have the what we have left actually does not take much anymore. The main this one is the one that you have from module 1 to 11. 11, that's what it is, 12. That's where most of these questions will come from. You have application layer in, and then 16 has to do with network security fundamentals, because this is also very important. And then the last one has to do with build a small network. I think that's where we'll do the project. I'll give assignment for the project. So do we
I
wish
think
to
by
write?
the time we finish the extra class,
Do we wish to write the exam, the
I
final
think we should be
exam?
able to.
Are we okay? We write this final exam next week.
Friday.
Okay, Friday. Are we okay Friday? So you have 1 week for it.
Next week, Friday.
You are still going to some people are, you are still going to do some lectures after the.
We still have some outstanding assignments and exam.
Yes, I will finish tomorrow by God's grace. And then I'll give you the whole week, the whole of next week for you to read and prepare. And while you're reading, I'll just give you. You said?
That will be fine. That will be better.
We use the whole of next week to do all the outstanding exams and assignments. And the upper week, we do the final exam.
Okay. Are we okay with that?
I think that's better. With some people that are lagging behind can use this next week for us to meet. We meet if online or physically to iron out any confusing area.
Okay, then I mean that would be, so that means we'll fix 28 as the exam. Do we agree? 28.
Come again?
I want to send the date of the exam to Cisco. Now we're writing this exam on the 28th for your institution. Do we all agree?
Okay.
Let me see the calendar.
Please, I have.
Friday is 28.
Yes.
Excuse me.
No.
Is the exam taken once or it's just like
Please,
once?
I have a question.
Yeah, exam is taken once for you guys as instructor. But then
Will the exam be
there's need for you to retake, sure. There's provision, right?
Please, will the exam be online?
Yes,
Yes.
the exam would be online.
Okay.
But we all come online, like that one, on the day of the exam, everybody will put on their camera. And then you make your desktop, of course, we will have to have access to your desktop.
Okay.
And also, you have the skill-based exam to write as well. So that means that we will take Thursday and Friday. We'll choose to do the skill-based exam first, and then the theory exam. So which one do you want to come first? If you want the skill-based to come first, then that will be 27. And if you want
I think the theory should
You
come
said
first.
it's
I think it is close.
You said?
I think it is close.
It's too
28. Yeah.
But
It's
our
going to be
lectures
like
are
a 2 weeks
started
time.
It's not really 3 weeks. Today is Thursday. Tomorrow
No,
is Friday.
2 weeks. 2 weeks.
It's 2 weeks.
And we see have other modules that we need to cover, and we have labs to take.
No, what I'm saying is that I'm running up tomorrow. Is that okay? And I'm saying once I round up tomorrow, we'll have the following week for maybe revision questions and then your practice and all of that. And then after which you now have your 1 week to prepare for the exam. Is it not okay? I'm going to send this thing.
Okay, from the reactions,
Yeah.
I want to suggest we make it 3rd and 4th then of February.
Okay. But it's not in our rules to keep shifting this thing like that. The way it has always been is at the end of the program, people write their exam. It's just that I've looked at the way you guys are running. We're running. You have a lot of things you're doing. So I'm going to be very considerate. But I think 2 weeks after the end of the program is fine.
The pressure here makes it a crash program. Because many of us at the end of the day, we still need to go over the materials. Yeah. It's not about passing the exams, it's about gaining the knowledge to be able to transfer it.
Okay, so let's pick a date now. Let me now look at the different dates. Or do I leave that? Do I leave that to you guys to discuss among you?
Yeah, I think.
Julius, we'll sit down together.
Yeah, sit down. I think it will be good for us to sit down together and
do that.
Yeah.
You know, at this point,
our course rep, Julius, we'll talk to you, sir.
Yes. Okay, at this point, okay.
Let me push it back to you guys.
Okay, thank you so much, sir.
But please, it shouldn't exceed more than, it shouldn't get to 3 weeks because we can't have the SWOT training class for 2 weeks and then we're having another lag period of 3 weeks of.
We will look into it.
So please just look into that and then. I know it's not really easy, but you guys should try. Just try, make effort. Okay, so on this note, I
appreciate you.
Thank you.
Yeah, please send us the video.
Yes, I will, and then I'll also send another pre-recording tomorrow.